And we are live. Welcome to another live stream. How about the sun-colored magnetogram? All right. I'm going to zoom in on this beast. Sunspot 2736. See how big we can make this. Not used to using Winamp for this purpose, folks, so bear with me. It's going to keep resizing itself, so let's just view there. So Sunspot 2735 is degrading. Sunspot 2736 is still growing. And we've got a coronal mass ejection headed toward the Earth. We're going to talk all about it in a minute. Let's close this down, play some more music, and get to some data. Here's a sun at 171 angstroms. Now this image here, this is just today. This is from 0 o'clock universal time through about the last 8 hours of solar activity. We like to look at 171 angstroms because it's great at showing magnetic loops. And when we look at close-ups of sunspots, this does give us some insight into what they are doing. All right, now let's look at some other data here. I'm just going to close this out. Before I go on, I want to let everybody know that the SDO has changed their format a little bit. When you're looking for custom views now, it's going to be a little different, so I'll just bring one up for you so you see what's up with it. We're going to load up just today, the last 8 hours of activity, and let's do 304 angstroms. Now this used to just show you right away. You can download frames or the movie. We'll pick movie. Now I don't know why they changed this around. They just basically made it more difficult for you to see the data. So you go link to movie, right? Now I've got a browser extension here called Tor, which is going to allow this to view correctly. So it's not quite the same as it was, but now that they've got it set up this way, we're okay with it. You just press loop, and there you go. So there's the view at 304 angstroms. Now this is just today. Now I want to show you one other thing here while we're on this view. There's a giant plasma filament right there, sitting in between those sunspots. That could become ejecta at any time. And the way magnetism works, that plasma could be slingshotted halfway around to the other side of the sun or directly toward Earth. Now, let's go back to the main SDO page. Show you the last 48 hours. Now, this is a longer view of the same thing because we had 2 C-class flares. There's one. You can see that plasma filament there. It looks like it's anchored to both of these sunspots. And that's, shall we say, interesting, to say the least. Because we've already got 1 CME headed toward the Earth, expected to arrive on the 23rd. We'll get into it. Let's look at the magnetogram here. full size look at the current state of affairs on that sunspot. It's gaining some magnetic complexity. Look at the leading edge of it there. We're getting a North Pole magnetic field association. So that thing is poised to produce more flares. The chance of even a thing like an M-class flare are continuing to rise as this sunspot continues to grow. That is not a shrinking daisy. That is a growing sunspot. All right, let's get off the SDO page here. I wanted to show you solarham.net to look at the LASCO C2. We see a partial halo here. Now, this is starting on the 17th, as you can see the date stamp. Let's make this as big as possible here. All right. You're going to see a halo come out. And when you see a halo on this, that means that the CME is headed towards you. Now, the majority of it is going to be to the west, which from this perspective is on this side, because you see a little greater density over there than around the halo. But that's headed toward the Earth, and according to the Enlil and the Cygnets predictions, the densest part of that coronal mass ejection is going to hit right into the Earth. So we will be watching it in real time, hopefully. All right, let's get off of this. Look at the LASCO C3, which gives you a zoomed out view of essentially the same thing. Give you a little more indication of the halo. Again, when we see a halo, and what we're talking about is when you see the CME around this area, that means it must be moving toward you. And there you can see it. There's even a second one behind it. That's from that second C-class flare. So let's look at their analysis here. This will show you close-ups of 171 angstroms. It looks like there's a flare going on right there in the view. Check it out. Pretty cool. Let's look at the real-time solar wind. All right, we're repeating the same song here. I apologize. This song, Gem Cutter, is available about nowhere. All right, so here's the real-time solar wind. We see a pretty bad phi angle here. Look, we rode 180 degrees for a long time, very close to the 180 degree mark. That is an earthquake risk factor if I ever saw one. Solar wind density has dropped all the way down to 3.19 protons per cubic centimeter. Solar wind speed has dropped down to 346 kilometers per second, indicating the coronal hole wind stream has ceased. Let's look at the gong 2 to check the magnetic environment. Load newest and hit play. So there's the gong 2. This data 2 hours and 5 minutes old. We crossed the heliospheric current sheet last night while we were doing our spring equinox fire video. Check that out. We live streamed it last night. Drank some beers, etc. There's the gong 2. Here's the last frame. Welcome to the other side of the heliospheric current sheet. You survived winter, and happy spring, everybody. The equinox was at 5:58 Eastern Daylight Time last night. Yesterday afternoon, I should say. Let's look at the line of sight field plot here so you can see the way the sunspots are affecting the B field, which is this blue region. You will see the sunspots pulling on the B field, as sunspots are magnetic phenomenon, like most things in the universe. You can see the distortions in the B field. Sunspot is holding back the B field. All right, let's move on here, as we don't want the video to be 2 hours long. By the way, for those of you not aware, I'm a terrible bicycle mechanic. And the reason I'm playing a clip from Kelly's Heroes is because when it comes to bikes, I just ride them. I don't know what makes them work.
Hi, man. What are you doing? I'm drinking wine and eating cheese and catching some rays, you know. What's happening? Well, the tank's broken and they're trying to fix it.
See, apparently Telly Savalas is playing one of these antisocial types.
Then why the hell aren't you up there helping them? Oh, man. I only ride them. I don't know what makes them work.
I only ride them. I don't know what makes them work. Here comes his other dog impersonation.
Definitely an antisocial type. That's my other dog imitation.
All right, let's look at some more info here. How about spaceweather.com? I could have sworn we saw an increase in the 10.7 centimeter radio flux. Indeed, we have. All the way up to 77, folks. Check it out. We are now way up here. Predictions were for us to be way down here. But instead, we're way up here. Congratulations. That's good news. So, Space Weather's talking about the CME, which we covered last night, long before anybody else. And that is why you ought to watch our channel. Speaking of watching our channel, who's here? Anybody? Anybody? Dear Chrome, please work. I don't know what's going on. There we go. By the way, instead of using Google, use DuckDuckGo.com. Even the Google Chrome browser will allow this to be installed as an extension. And I'm sure they love it. Oh, googlesucks.org. Check that out. Sounds like a hell of a site. MetaLink Technology, some other search engine. That's all good. Anybody besides Google. All right. Tune into our own live stream here, creating some kind of crazy paradox in the universe, possibly creating quantum effects that erase our very existence. Just kidding. I don't think that works that way. Good morning, Trigger Ready News. Like the name, Trigger Ready. You must have great trigger discipline. Welcome, Christy H. and Trigger Ready News. Which reminds me, to suggest that you check out Pat McNamara's websites and his Instagram page and his YouTube page, which is right there. I'll bet that's not the right Pat McNamara, but this one is T-Max Inc. Look him up. He's taken military tactics to a new level, and yeah, he's doing some firearms training for everybody from the novice to the Delta Force operator. So check out his Instagram page also. Thank you, Pat McNamara. De Oppresso Liber. All right, let's go to spaceweathernews.com. A great site thanks to Ben Davidson. Please load. It's not secure, and neither are you unless you are prepared for coronal mass ejections and other disasters. All right, I don't know what's going on with these pages. They are making me mad, so I'm going to close them. All right, you need to load Space Weather News. All right, so there's the C-class flares. This one right here. Wait a minute. One of these happened while one of these B-class flares. Basically, we B-flared all day yesterday. So we actually had a flare going on during our live stream in the morning and the spring equinox fire live stream. So that was interesting. We're going to see a little more of that going on in the future as solar activity is increasing. Now, let me take a moment to show you the signets forecast. The CME has been rendered. There's going to be a massive flux in the current sheath, whatever you want to call it. Also, I would note that one of my favorite science devices, Parker Probe, the Parker Solar Probe, is approaching maximum velocity as it's making its second solar pass. Still waiting to see data on that. I don't know if any is back yet. If anybody has any, please post it in the comments. By the way, we have all our links in the description, so please visit those as well. Let me play some more music for you. All right, what else do we got? So here's the magnetometer. We were crossing the heliospheric current sheath last night, right when we were making our live stream, as Snowflake Vaccine aptly informed us. So well done on that, Snowflake. We appreciate it. KP was down at 0 for a little while. Now it's back to 1. Slight cosmic ray risk. We'll look at it. There's the electron flux. Nothing too special there. Charging hazards are non-existent. And the F2 layer is looking pretty basic here. Pretty basic. A little discharge on the nighttime side. Not particularly charged anywhere. Nothing to really write home about. Let's look at the cosmic rays real quick. Here's Apatity and Barentsburg, which are located on Svalbard and Finland. There's a cosmic ray environment in those locations. We're expecting a downtick in cosmic rays as solar activity increases. So for that, we thank you. There's Athens. We are calling them like we see them, no matter what we see. I don't know what I clicked on there, but I didn't mean to. Here's Mexico City. We would look at Moscow, but they're not showing data. I apologize. Barentsburg is not in Finland. Barentsburg is in Russia, actually, near Finland. Here's the OLU monitor, as well as DOMC and DOMB Antarctica. So there's that. Here's DOMC Antarctica. Little uptick there, not returning hourly data again. And there's DOMB Antarctica, also not showing hourly data. Maybe they're on vacation. Anyway, there should be links to all that stuff in the description. Let's look at the Space Weather Enthusiast dashboard. First, we're going to look at the visible light. You'll be able to see what the sunspot would look like through a telescope if you had one in space. So there's the visible image. Can I blow it up? Can't blow it up. Oh, I can blow it up. All right, cool. Excellent. Now that sunspot is spreading apart a little bit, but the leading portion appears to still be growing. So you can kind of see what's going on with it there. There is some complexity kicking off in the front. And remember, folks, just because a sunspot is not Earth-facing does not mean it can't hit you with a coronal mass ejection. These things can be anchored to the sun, and they can swing halfway around the sun. You can get hit by a coronal mass ejection when a sunspot's not even facing the Earth. We see those C-class flares coming off. Shrink this down here. There's the 1C flare. There's some B flaring. There's a C flare. That's a C-class flare right there. And there's another C-class flare. Wait. There's the other one that was a real quick pulse. And that's the GOES X-ray imager. Here's the Enlil forecast, which is a little different system than the Cygnet's forecast. It does show the densest portion of the plasma plowing right into Earth's magnetosphere. So we're looking for, they're expecting a plasma density spike not greater than 30 protons per cubic centimeter, and a small uptick in the velocity on the 23rd, around midday universal time. So that's the forecast. We're going to look at the space weather beacon again so you can actually see the instrumentation of that coronal mass ejection. There's your aurora forecast. Nothing too exciting there. We do have a small uptick in relativistic electrons also. We're not going to cover it today because there's too much stuff. Here's the regular total electron content forecast. This will show you, this will give you some idea of any GPS errors you're going to get. And if you're in North America, you're going to see some. Northern Australia's got tons of GPS errors. So a little bit of GPS errors. I do use GPS on a daily. Here are your magnetosphere movies. And we're expecting some weak, magnetosphere. So here's the velocity, hopefully. Come on, you can do it. All right, so there's the velocity. And we're going to see a very weak magnetosphere as we see a very low density and low speed solar wind. So we like when the data corroborates itself. And there's the velocity. Nothing too extravagant happening there. Here's the density. You're going to see the density dropping down probably in this video. Not really dropping down too much, but you do see low density solar wind coming in from the left of the screen there, as you would expect with such a weak solar wind. Here's the pressure. Fairly equal distribution here. So the magnetosphere is in a charging mode right now, which is not good if that stays like that until that coronal mass ejection shows up, because the less charged this is, the harder the relative collision with the plasma. So coronal mass ejection expected to arrive on the 23rd around midday UT. So about something like 4 hours after we usually do our video. Let's look at the ground magnetic perturbations. We don't really expect to see very many, but let's look anyway, as this stuff is all related. Science is a rabbit hole, and if you're doing it right, you're probably going to end up with more questions than answers. So welcome to the rabbit hole. Oh, from the Choctaw tribe. Nice. Where's the Choctaw tribe located? Oh, yeah. We were covering the flares before everybody else. We have not even yet reached 1,200 subscribers. If you're an influencer, please share our videos. We're not frustrated because the main reason that we do these is for our family and friends. We just figured it would be a value-added service to share them with the whole world. All right, let's look at the ground perturbations at the global scale. Yes, please add my channel to your list. We appreciate subscribers, donors, regular everyday viewers, people who press the like button. Please turn on notifications, as when something happens, we go live without any warning. Oklahoma. Okay. Cool. All right. All I do is given freely too, but I would like to receive monies because I need a lot more than I have. All right. There's your cosmic rays. And we see an uptick in earthquakes. Oh boy. What do we have? Look at the last 24 hours. What is that? 6.3 at Vanuatu. All right, let's go down the list. Before we look at the list, let's draw in the watch zones. If you're in these areas, I implore you to have an earthquake plan. Low solar activity and coronal holes are associated with earthquakes. Solar minima, volcanoes, earthquakes, all correlated. If you're in those areas, be an asset instead of a liability in the event of an emergency. Got it? I don't want to beat a dead horse. 4.9 in Bamboo Flat, India. 4.4 in an odd location in Alaska. Here we see a 3.2 in California. We don't usually report anything under a 4, but all right. Here's another unsettling quake, to say the least. 494 kilometer deep, 4.7 magnitude, right in the watch zone. See what I mean? See what I'm saying, folks? Earthquakes are now predictable, so learn how. We go over it regularly. Watch one of our older videos. There's the largest quake we've had in a long time, a 6.3. Vanuatu got hit by that one. That was not a good day. Looks like not too much damage. Little or no effect. That's good. Let's take a quick moment to see what's going on at tsunami.gov, as we haven't seen anything updated since the 13th. Still not updated. Well, no tsunami warning, advisory, watch, or threat. That's good news, right? All right, so we also see a 5.1 in Ecuador, also right in the watch zone. Have I mentioned that I hate this map? 4.5 in Japan. 5.4 in Tonga. Pretty big quake at the surface. Northern Mid-Atlantic Ridge. 5.0 magnitude. It used to be rare, but during this solar minimum, it has become common once a week or so. 4.6 in Pakistan. 4.5 in the Philippines. 4.3 in El Salvador. 4.8 in Tonga. Talk about a hotspot. Another 4.7 at New Zealand. Let us know if you felt that one, our New Zealand viewers. We know we have a few. Burma with a 4.3. You may call it Myanmar, but it'll always be Burma to me. 4.3 in Russia, near the Kamchatka Peninsula. Kamchatka, however you say it. A 600-plus kilometer depth quake at Fiji. Man, that is a deep quake. All right, there ends your quakes. Let's look at volcanodiscovery.com and check on the today's volcanoes. What do we have? I see something exploding here. Stromboli is back to erupting. At the same time, we see a 600-kilometer deep quake at Fiji, the exact opposite side of the planet from Greece. So I find that scarily, eerily correlated. So Stromboli back to erupting. Explosions at irregular intervals. Mount Manam producing a 15,000-foot ash plume there. 10,000-foot ash plume at Bromo. relatively new to the list also, Tucano, 7,000-foot ash plume. Don't try to jump over it. Fuego with a 16,000-foot ash plume. New emissions at Reventador. Savanchaya, 27,000-foot plume there. And that's the star of the day so far. Also, Planchon Peteroa with a 14,000-foot volcanic ash plume. Let's go a little farther away from home to Zooniverse.org, or Galaxy Zoo, one of the largest citizen science projects in the world, where we classify galaxies on the daily. By the way, people have been publishing scientific papers, so set yourself up a login and help us classify some galaxies. I see features. Do you see features? Is there a bar? I'm going to say no bar on this one. Is there a sign of a spiral arm pattern? Well, certainly not. Is there a bulge? Well, certainly so. We'll say moderate. Is there a disturbance? I don't think there's a disturbance. Do we see features? Yeah, there's some stuff. I'm going to say lens or arc. It's not irregular. I see dust lanes. I'm going to say overlap. Keep in mind when you do this, you're only classifying the galaxy in the center, not any satellites or related things. You got to only look at the one galaxy. And the reason we have this science project in effect is because we need human eyes to classify these galaxies. Computers are incapable. And there you go. There's a galaxy classified. Will you be the citizen scientist to classify this one? Check it out. What a group. Get on it, people. Next, we're going to look at the space weather beacon, as we usually do. Now, we looked at this last night, long before any other channels covered it. We're going to let this play stock, and then we're going to add some frames. All right, we don't even have the CME on there. All right. Now this one does load the most current frames. We're going to go to 100. We're going to load 10 times as many frames at 3 times as many frames per second. See how that works out? Should show the CME here. And there's that CME associated with that C-class flare last night. And there's a second flare behind it, and that didn't produce any ejecta. So this is a great demonstration of the difference between a flare and a coronal mass ejection. Know the difference. When we talk about a solar flare, that is an X-ray event. That is electromagnetic radiation, which arrives at the Earth only 8 minutes or so after it exited the sun, the X-rays. Coronal mass ejection is primarily made of protons. Also, helium nuclei, known as alpha particles, those want electrons really bad, just like hydrogen nuclei. There's also electrons in there, and all of the elements known to man, because the sun makes all the elements. If you weren't aware, a lot of astrophysicists probably are not aware. The sun makes all of the elements. Every element on the periodic table is in the solar wind. Anyway, there's your coronal mass ejection. Don't say we never gave you nothing. Let's play some more music. Did we play that one already? Let's put something different up here. How about, oh man, how about diced carrots? And some brass. Got some brass in the music here. And some salsa-esque beats. Here are the planets today. Let's refresh just to make sure. I wouldn't want to show you the wrong planetary locations. By the way, if you're wondering where Stereo A Space Beacon is located, Stereo A Space Beacon is located right about here. Stereo B, which has been damaged since 2014, is located about here. So when we look at stereo A, we're looking at the sun like this, and that coronal mass ejection we were looking at is aimed like this. My brush is too big. I can shrink it down. Let's do that. So just wanted to give you that little visual there in case you're not aware of stereo A and B. Let's advance this 7 days as we usually do. There's where the planets will be 7 days from now. And that's a short song. What else do we have here? Got some old songs. Jeez. How about this one? I know we got a lot of Al Gore fans that watch our channel.
The Americans have semi-automatic weapons. This is Al Gore, and no matter how many automatic arms I get, I love all the Americans.
All right, I don't know what that was all about. It's undoubtedly my fault, though, because I produced all of the music. Here's one I clipped from Jackass. And here's a real song. All right, let's move on here, as we don't want it to get too long. If you haven't subscribed to the channel, please do so. YouTube.com/smAsho. There's a lot of stuff going on. The channel's growing. We're working on collaborations every day. And David Devine, if you're listening, we haven't gotten the chance to go over those talking points about the David Wallace Wells thing yet, but we're going to do it today, as we're going to actually have some free time. We had about 5 seconds of free time yesterday. Busy. So it's better being busy than bored, folks. Here's weather.gov. Just give you a quick overview of where the warnings and stuff are. Not going to go too in depth into it here, but there's the situation. Tropical tidbits. Oh, what the hell? Let's load it. It's the 250 millibar wind on the world view. And what am I missing here? Get that to reload. Well, that's not a forecast, is it? Anyway, there's a jet stream. It's all jacked up. Let's move on here. Here's a U.S. Doppler radar. By the way, we are almost done, folks. If you have any questions, concerns, comments, hate speech, etc., please leave it in the comments. I'm going to be reviewing them in a minute. Make sure that's updated. There's a U.S. Doppler radar. We got heavy storms in the southeast. More rain in the east central U.S. and all kinds of scattered showers and stuff all across the whole country. Utah getting hit with some snow and rain. Arizona got some snow near the California-Nevada border there near Tahoe. By the way, if you're on Instagram, follow us there if you like. There's some behind-the-scenes stuff. Some stuff that you won't see otherwise, such as videos about my tomatoes, which I still haven't harvested, by the way.
Oh my gosh, it's the last ride of the
That tomato's been ripe for a while. And I still haven't harvested it. There's my fat goldfish, Jaws and Phelps.
What did you do with the final hours of your winter? I rode a single speed bike all around on the road with some aero bars. Happy spring, if I don't see you before then. Yes, last ride of the winter on a single speed. It was 919 feet of climbing. in a 46 by 16 gear, I believe it is. Now time for some tomatoes.
We've got videos on top of videos on top of videos. By the way, if you're thinking about bicycling, head to veloshop.net. Get yourself some ideas. Little history of the Velo Shop. Founded by world cyclist Becky Quinn, local cycling favorite. Here's a quote from three-time world champion and Olympic gold and silver medalist Marty Nothstein. This is my shop. I've raced bike all over the world, and I can say the Velo Shop is a world-class shop that takes a backseat to no one. Becky, pictured here, has put together one impressive operation, and I would tend to agree with Marty. A guy that I've never had beef with. All right, let's go back to the sun. Let's take the most recent image at 94 angstroms, as it looked like a flare was jumping off yet again. That sunspot is not going away, and it is not deactivating anytime soon, folks. Let me head back to the chat here. Oh, wow. Choctaw royalty, huh? Interesting. And here we've got 94 angstroms. Let's full screen it. It's a great view, by the way. Non-regular viewers. One of the reasons why we look at 94 angstroms is because it takes 5 times as many photos as the other SDO scopes. So it's a good way to zoom way in. If you want to look at some of those custom images, we showed you how to do it earlier in the video. If you're just joining us, just start over from the beginning. It's all good. Thank you, Trigger Ready News. I appreciate you showing the channel. I don't know how many subs you've got, but I really appreciate it. The funky jet stream is because of the weak solar wind, largely, yes. The moving magnetic field, we're not so sure on that one. It doesn't follow the solar cycles. So there are some people out there that are working to measure this polar excursion. And just to give you some insight into that, those of you not aware, let me go to the ground perturbations map here so I can kind of give you a little drawing. I think it's this one. There we go. Let me zoom this out a little bit to give you an idea of how this works. I know we had some viewers that liked this diagram the last time I drew it, so let's draw it in again here. All right. Now, the solar wind comes in like this. Now, this is not to scale, folks. Solar wind comes in, and it hits what we call the bow shock of the magnetosphere. This is the point of greatest resistance. When that happens, this splits into field-aligned Birkeland currents, which go like this. All right. These are both Birkeland currents. There's charge going both directions through both of these currents. When they reach the Earth, they're going to go right through the planet like this. That's why we see current going in, current coming out. This process, this current flowing through the planet, creates the Earth's B field. So just like the one from the sun, there's a field that comes out like this. And it kind of surrounds the planet. Just like the sun's B field, the Earth has a B field. Now, up here, let me get rid of this for a second. In this region, we've got a pole here and a pole here over Siberia. One over Canada, one over Siberia. South pole is going like this, up toward Western Australia, the southern Indian Ocean. Now, if you take a compass, your needle will point to this area. That's the product of the two North Poles. All right. If you start to move over toward this pole, your compass will eventually point toward Siberia. If you move toward this pole, your compass will eventually point toward Canada. Because if you're too far away from the product, you're going to get the field that's strongest pertaining to where you're located. What does that mean? The short answer is we don't know. But the goal is to measure this. Now, the real danger is if any of these poles move down to about here, about 40 degrees, if they move down to there, we are expecting weak field lines, all right? If we get weak field lines when the solar wind comes in, instead of just neatly splitting and going to the poles, it's going to not neatly split. It's going to come in and it's going to just go all over the place. It's going to, put it this way, if you see auroras on the equator, that could be a problem. Now, you can get auroras on the equator because of a massive coronal mass ejection also, but that doesn't mean that the magnetosphere is like totally screwed up. What we can't tell from the geologic record is exactly how this works. There's some indication that a polar flip can happen in just a matter of a few years after it has undergone an excursion as great as the one we see today. So that's all I'm going to say about the pole flip for now, because this stream is getting long and we don't want them too long. Although our viewership is going up and our average watch time is going up massively. So yes, the funky jet stream is because of the weak solar wind. The weak solar wind is associated with a weak magnetic field. You know, sometimes the data is a reduction in activity, not an increase. Everybody looks for spikes on the data, but you got to look for troughs also. Got it? All right. So, hey, thanks everybody. We're going to be on here regularly. We do this every day. We appreciate you viewing. We'll be doing it all again tomorrow, if not later today. So stay tuned for a lot more stuff as stuff is coming out on the regs. Thanks, subscribers, donors. Please don't forget to like and subscribe. Share on your social media, as we are shadow banned pretty much everywhere, give or take. And it'll never be now again. So thanks again. May the solar wind be at your back and the atherosclerosis absent from your veins.